Redgate!
Thank you. So I'm Chris, and this is my talk on SSDT database projects or Visual Studio database projects. Hopefully no one here is expecting me to be talking about changing the way we do DevOps or common ORM problems. If you are, now's the time to jump out and go and join one of those sessions instead. Before we launch into this properly, just want to say a little bit about me and why I'm talking on this subject rather than anything else. So you've got my contact details up there on the screen. Please feel free to contact me after this if you have any questions or follow-up queries, anything like that. I'm really very happy to help. So I've been a SQL developer now for about 15 years. And for the last 6-7 years, I've been working more and more with database projects. And when I started out using them, we were just using them really as source control, nothing more. So we'd develop on dev database, and then we'd use SQL compare to move whatever we've developed into the Visual Studio project, and then SQL compare again to publish that out to live. And that was kind of okay-ish. We had source control, but it was kind of frustrating and we were running into issues. And as time went on, I've worked with other people at other companies, and I've learned more about how you publish out from Visual Studio and a few things about how you can use it. And then the last few years, I've been working with some .NET developers. And they've really helped me to see, because they're more familiar with the Visual Studio environment, they've really sort of opened my eyes to the full scope and scale of what this tool can do. So that's really the aim of this talk here. We're not really going to dive into the basics of Visual Studio database projects. Instead, I'm going to talk a little bit about what a project really is. So what is kind of going on under the hood, and what are the things you can include in a project. Some of the extra development capabilities you get when you work with this technology. Some of the interesting things you can do with your project settings and your deployment options. And then we're going to spend a fair bit of time looking at references from one project to another, either as a different database or as a different part of the same database. And that is, in my opinion, the most overlooked and most powerful feature of this technology. So we'll start off with what is a database project really? So what is happening under the hood when you open up Visual Studio and you open up a database project solution and you see something like this? The first thing to understand is the project is not a database. There's no direct link between that project and any particular database out there in the world. It's really a collection of files. And they're mostly SQL files, but there are some other file types in there as well. And like any file, you can open these up with pretty much anything and edit them, like Management Studio, Notepad, Visual Studio Code. You can open up these files, make changes with those editors, but really, I wouldn't recommend it. You want to be using Visual Studio to get the full benefits of working with a database project. Now, within Visual Studio, you can trigger a build, and that effectively takes all of these files here and summarizes them in a single DACPack file. So that DACPack file is going to hold the schema definition of the object, and it's also your deployment artifact. What I mean by that is, in Visual Studio, again, you can trigger a publish, and that publish, first of all, triggers a build. So you have an up-to-date DACPack, and then it deploys from that DACPack out to a particular database. Now, these build processes and publish processes can be triggered outside of Visual Studio through things like PowerShell or a command line. And I do recommend looking into that. That is how you get your automation, your continuous integration, continuous deployment, DevOps goodness that everyone really wants. And when I say that the database is not the project and the project is not the database, you can see there's no link going that way at all. Any changes here don't get reflected here. And any changes here only get reflected in the database when you publish out. But you don't have to publish to the same database every time. You can publish out from here to anywhere. There's nothing that says this has to go to this particular database. So there are a few things to bear in mind when you are working with database projects in Visual Studio. And the first thing is always code in Visual Studio. And that may seem like I'm repeating myself a little bit, but even when you're working in Visual Studio, there's a bit of a temptation to write your code in Management Studio and then copy that into your Visual Studio script. But that's always going to cause more headaches for you, and it's not letting the tool help you. Similarly to that, the tool offers you a bunch of other help if you work with it. So there's a number of points where you can use an interface within the tool to do things like rename or change schema rather than going direct in the script and making those changes. Always do that. Always use the interface where it gives you that option, because if you do that, it can help you. And we'll get to exactly how a little bit later. And finally, remember you're always working to develop a code base. You're not writing scripts to run against a particular database. Instead, you're defining what you want this object to look like post-deployment. So you always use create scripts within Visual Studio, and you let the deployment decide whether it needs to be a create or an alter. Now, these objects you're developing, usually your standard tables and views and store procedures, your usual database objects. And they live inside these SQL files, one per object. And when you create one of these files, you will be asked to choose a name, and that defines the file name and the object name, but those things don't have to stay synced up. You can change the file name in the script through the interface. You can change the object name in the script or using the refactor option. And they do not have to stay synced up. And it's the object name that's really important. Similarly, you'll be asked for an object type. And all this does is it generates a little SQL template to create the object with whatever type you've selected. But again, you can change that. Maybe you're developing a view and you realize after some time that it shouldn't be a view. You actually need it to be a function. You need to be able to parameterize it. So you just change that statement to be create function. So mainly the behavior of an object is going to depend on what you put in that script. But it also depends on the build action property you apply to that script. And that's just a standard drop-down in the property window for that file. And I've highlighted the important values, sort of meaningful values on the right there. And the two really important ones are build and none. Build means this is a standard script, include it in the project validation, include it in the DAC pack when you build, all of that stuff. And none means ignore this script completely, pretty much. Don't include it in any validation, don't include it when you build the project. And there are reasons that you'd have a script as none. And those other three we're going to cover in a little while. As well as those standard objects, you can also include a few things you might not think of, like users or logins or linked servers. Now, a quick thing to note here is even if your project only contains server level objects, so linked servers and logins and stuff like that, you do still have to deploy it against an actual database. There has to be some database there on the server that you choose as your target. And a really important thing to bear in mind is the sort of established best practice is these objects are under the control of the DBAs. They're not usually something developers will be controlling directly. And by bringing them into a database project, you're putting them under the control of the developers. And I'm not adverse to going against established best practice, but I do think you need a reason, and you are definitely going to need to discuss it with devs, DBAs, and other interested parties. The first of these, well, the first two of these specialist build actions I was talking about are pre and post deployment files. And these kind of do what they say on the tin. These files will be run at the start or end of a deployment. And usually you use them for static data, lookup data. So you've got, maybe you have a table that wants to hold some standard error codes and you want to know it's populated with these 5 error codes every time. So you write a merge statement in your post-deployment file to populate that table. But you can use them for other things. Really, you can use them for anything you can script out. So say you know there's half a dozen SQL agent jobs that need to be there for this project to run. You can script them out in a post-deployment file as a drop and create or something like that. Just a quick note, you can only have one of each of these per project. If you try and create more, you'll run into problems. These files also use the SQL CMD language, which is actually the language your deployment script will use as well. And this gives you a few extra coding options beyond regular T-SQL. First thing is you can throw in some references to other scripts. So like we were talking about with those, that static data, maybe you have 20 tables with static data and you don't want to write 20 merge statements in one script because that gets kind of unmanageable. So you break that out into 20 separate scripts. And each of those scripts will have a build action of none, but you'll then put a reference in there from your post-deployment file, or 20 references, one for each script, and they'll execute in order. And a little thing to bear in mind with these scripts is those references can be relative. Those file paths can be relative, and they really, really should be. And if you're doing a relative file path, then the other scripts need to be inside the same source control repo. They don't necessarily have to be inside the same database project, but definitely inside the same repo, so that when you're moving this code around, and especially when you're putting it up on your automation server, everything still works. And the other SQL CMD thing I want to talk about is variables. So you can get a little creative with these. So in the example I've put up on the screen, I've set a clear DB variable. Whenever I deploy, I can set the value for that. And if I set that value to 1, I'm going to execute this clear database procedure, which is just going to empty the database of all data. Hopefully you can all see why you don't want to run that every time, but you may want to run it fairly regularly on dev. And this gives you a nice way to control when that runs and when it doesn't. The last specialist deployment action is the refactor log. This is a file that you don't need to touch at all. Visual Studio automatically maintains this for you. And it tracks any renames or schema changes that you do through the interface, and only ones you do through the interface. So for instance, if someone has set up a customer table and called the ID column customer IF, and you want to change that to customer ID because it drives you crazy, if you rename it through the interface, then when you deploy, the deployment process will just execute a rename on that column. If you rename it in the table script, then when you deploy, the deployment process will drop the column and create a new column called customer ID, and that's almost certainly not what you want to do. Finally, because everything you're looking at here is a file in a folder structure, you can rearrange that folder structure however you like. Visual Studio gives you a couple of suggestions, but you don't have to follow those. You can really do whatever you want. This is, again, something you want to discuss as a team, come to a decision on as a team, because you don't want everyone trying to manage things in their own folder structure. You can also take certain objects that usually hang off other objects, like triggers or extended properties, and put them in their own script. So the standard in Visual Studio is for a trigger to be in the same script as the table it hangs off, but you can move it out into its own script. And by doing that, you can maybe have a script for table A and then another script called table A_triggers. And you can then see really easily that table A has some triggers on it just by looking down that list of files. And finally, as I said before, you can rename the files without having any effect on the objects inside them. So maybe you want to put numbers in front of your files to keep them in a more sensible order than just alphabetical, something like that. That is the end of the first section. Are there any questions in the chat yet?
I don't see any, Chris, but I'm not certain I can see all of them. So I'd carry on.
Okay. Next section, we're going to take a little look at some of the nice stuff in Visual Studio that helps you out with your coding. And the first bit is a few just little quality of life improvements. So we're coming back to always use the interface for renames and refactors. And this is because when you do that, those changes propagate through the entire solution. So in our example before, where we renamed the customer IF column to customer ID, every other script in your project that references customer IF on that particular table will now reference customer ID. And it's smart enough to tie it to that table and nothing else. The other little feature, if you're doing some sort of code investigation, something like that, and you've opened up a stored proc and it's calling another 10 stored procedures in there, if you highlight one of those objects and hit F12, you will open the script that defines that object. And it's just a nice little time saver to mean you don't have to go hunting for these scripts every time you find something like that. And this is what that refactor looks like. You just right click on an object in the script and you get these options. Continuing our theme of these projects are not databases and these scripts are not objects, you can write comments on anything you want. Things like tables and schemas where the comments won't persist on the actual database once you deploy, they will persist in the scripts you've written in Visual Studio, which should now be where you're doing your coding anyway, so that's where they really matter. Similarly to that, if you're encrypting your stored procedures and views because maybe you're deploying to somewhere where a client can see and you don't want them seeing your IP, then you can still see the unencrypted versions in Visual Studio. And that's just really handy. And finally, there's some really nice extra validation stuff you get within Visual Studio. All the scripts validate with the same IntelliSense that we know from Management Studio, but with the bonus that because everything here is concerned with the project, if you make a change that causes any script to now have errors, those errors are going to show up in the error tab in Visual Studio. So you change a view and change the name of a column or cut a column off that view, and some stored procedure elsewhere in your project now doesn't work, you'll instantly see that. And when an error comes up in that error tab, if you double click on it, it's going to open up the file that has the problem. And it'll be highlighted in the usual red squiggly lines, all of that. Now, there might be some errors that you see where you think that's actually not an error. I know that when I deploy this to a database, it's actually going to be fine for whatever reason. And you do have the option to suppress these errors. You can either suppress them throughout the entire project, or you can just suppress them for one script. So either way, you take this error number here and you just copy it into this suppress warnings box here in your file properties tab. And you might notice I've got 2 errors up on the screen there, but there's only 1 error in the actual code. And this is because I've incorrectly named a table, so it's thrown up an error for that. And then I'm referencing a column from that table, so it's thrown up a second error for that. So if you ever look in the error list and there's 20, 50, 100 errors in there, more, I've seen error lists of thousands before, then don't panic. The chances are maybe 1 in 10 of them is a genuine error. So that's the end of this section. Any questions on this?
There are no questions that I've seen so far.
Okay. Well, this next section is taking a little look at what you can do with your database settings, your project settings, and your deployment options. So first thing, as we discussed, you can suppress error types at a project level rather than just a script level, and that works exactly the same as the script level. You just copy the code into the appropriate window. You can also add some extra warnings to your project, and the project has a number of options you can choose from here. It's quite a few. So this is, again, probably something to discuss with the team and come up with something that meets your overall coding standard. But you can, for instance, set up a warning if someone uses select star, or if someone uses a like predicate that starts with a wildcard, because that's a performance issue, or if you're using reserved words in names, or, like I say, there's a lot of options there. Have a look at them as a team and decide if there's any you want to add into your projects. And there's also an option to set any T-SQL warnings as errors. And I would usually recommend turning that on. Partly because people will usually just ignore warnings, or warnings are easy to ignore. It's maybe the nicer way of putting that. And partly because of the way T-SQL handles stored procedures. So in a stored procedure, if it's referencing an object that doesn't exist, that's only a warning. Your create statement will still run for that procedure. And usually you'll want that to be an error. Unless you're using some sort of design pattern where you create an object in one procedure, use that object in a second procedure and drop it in a third procedure, which is something I have seen used. So if you are, probably leave warnings as warnings. There's a few other settings that you can look at in your project. You can control your database settings. Again, this is something you usually want to leave up to the DBA, because here we're talking about stuff like recovery model and whether service broker is enabled. But you may have good reasons to want to control those settings from inside the project. And if you do, the option's there. You can create new SQL CMD variables. So that clear DB variable I used in the example earlier, that was created by going into project properties and finding SQL CMD area and just typing in a new variable name. And finally, you can control your SQL version that the project is targeting. And it's important to get this right, because if you have a project that you've said is a SQL 2019 project, and you try and deploy it to a SQL 2012 server, then Visual Studio just won't let you. Now, there are quite a few other things that show up in this, in project properties, but I'm not going to go through all of them, because as you can see, we'd be here for some time. Instead, move on to what we can do with the deployment options. And when you deploy a project, you're usually prompted for two things. You're prompted to set the value of any variables within the project. And this is your way to make that project behave a little differently for different environments or even different deployments in the same environment. You also have you will also be prompted to set the connection string, and this includes the database name. And the key thing here is that database name doesn't have to be the project name, and it doesn't have to be the same every time. This project can deploy out to any database, really. And you can even do things like deploy the same project several times to different names, therefore creating several databases on the same server. And you might want to do that because you're developing a few different features concurrently, and you want to have an area on the dev server for each different team to work. Or maybe you're looking at some performance improvements and you want to have a baseline version of the database still. So you'll create two branches in your source control and deploy out to the same database from each branch. And like with the project properties, there are a number of other things you can do with deployments. A couple of major options. You can choose whether you include the database settings or not. As we said before, you will usually not want to, but the default in Visual Studio is to include them. So remember to turn them off for every deployment. You can choose whether you want to drop objects that are in your target database and not in your project. And the dream is to get to a point where you're comfortable doing that. But that's not always going to be possible. It's probably going to involve some conversations with other teams, maybe even outside of the IT department. If, I don't know, you maybe have some analysts who are querying your database regularly and they want to set up views and things. If you switch this on, you'll wipe all of that for them. So, although I say the dream is to get to a point where you're comfortable doing this, if you're not comfortable doing this, don't. The worst thing you can do is switch this on if there are other people doing work on that database and wipe their stuff. And finally, you can choose to exclude certain object types from your deployment. So maybe you've needed to include a user or a login to make some of your code validate properly, but you don't want to actually be controlling that security stuff through Visual Studio. So you just say, we're not going to deploy these object types, we're not going to include them in our deployment. And again, there's a lot of other options here. I'll leave those up to you to explore. So it's the end of that section. Any questions on that?
No, nothing yet, buddy. You're explaining it all brilliantly.
Okay.
What he said.
So this next section is quite quick. I'm going to quickly look at other database references. And this is where you want to refer to an object from another database within one of the code objects in your project using a three-part name. And as you can see from the screenshot, there's a few ways you can do that. You can just directly refer to another project in the same Visual Studio solution, or you can refer to a system database like master or MSDB, and that's usually because you want to use some of the sys objects that need master. Or if you want to refer to a project that's not in your solution, then you can refer directly to the DACPack file that comes from building that project. And something to remember there is that those file references, although they look like they're an absolute path, they are actually relative. And therefore, that target DACPack needs to be inside the same source control repo as everything else you're working with. Otherwise, again, when you move your code around and when you put it up to your automation server, it's not going to work properly. And the other thing to note that helps explain a few of the weirder quirks of this system, all these references actually are referring to DACPack files. Even those master and MSDB references will refer to DACPack files that got installed on your machine when you installed the SSDT projects add-on for Visual Studio. And this helps explain why a few of these things happen. So if you set up a reference to another project and then make a change in that other project and don't rebuild it, the DACPack of that project won't contain the change you've made. So you won't see that change in your original project. So if you ever find yourself in a situation where you're making changes, but they don't seem to be coming through properly, you probably want to rebuild some stuff somewhere. So just do a blanket rebuild usually helps out there. Because of the way the validation works, you also need to include all dependent references when you set up a reference. And what I mean by that is if you have a complaints project, and that's referencing a bookings project, and the bookings project references a customers project, complaints also needs to reference customers. And finally, if you've got, say, a SQL 2016 project, and you've set up a reference to master, that's actually referencing the master 2016 DACPack on your machine. And if you change your project to be, say, SQL 2019, that reference will stop working. So, but it's a really easy fix. You just have to delete the reference and create it again. And by creating it, it'll point at the correct DACPack. That's it. I said this was a short session, or short section rather. Any questions on that little bit?
Hey, Chris, this is John. I have a question about actually your previous section. I apologize if I can.
Yeah.
You had shown briefly the code analysis in SSDT, and I've played around with that before in the past, and I've always found that kind of to be lacking in like flexibility and what you can do. In your experience, have you played around with anything else outside? Like, I know of one third party that kind of does that. I've always found that to be kind of a sticking point. What's your experience with that?
So what do you mean by lacking? What are you trying to do that it can't do?
Well, in a former life, when I was doing database development type stuff, we always had very specific organizational requirements to do certain levels of code sniffing for certain things. Like, I got to make sure the scripts don't have passwords. I got to make sure that we're not granting or denying permissions on database objects. We were always, there's always a lot of red tape, excuse me. And so the native code analysis stuff I always thought was not robust enough to meet the organizational requirements I had. And that's almost always what I've always experienced. I was just curious to see if it fits your needs, that's totally cool. But if you had ever run into where it doesn't fit your needs and how you solved it.
Yeah, I've never really needed to do that kind of thing.
Okay, cool.
If I did, I would probably set up some sort of automated testing to run on dev to check for that kind of thing rather than doing it within the project, because I don't think the project supports that kind of analysis.
Okay.
Yeah, there may be some third-party tool you can use for it.
Okay, cool. Thank you.
Okay. So we're going to move on here to what I think is the biggest overlooked feature in database projects, and that's same database references. That's where you refer to another project as if it's part of the same database as your project. And very quickly, I'll take you through an example. So here, I'm trying to build a complaints database, and I've decided I want to split that out into 2 projects. So I've got one project here called complaints tables, and that's going to hold all of our tables. The second project called complaints code is going to hold all the views and procedures and everything else that sits on top of those tables. And then I set up a same database reference between the 2. And to set that up, it's pretty much the same as setting up another database reference. It's just a different option on one of the drop-downs. And what this is going to do, effectively, is it puts a virtual version of complaints tables inside that complaints code project. And now, code can reference tables. Tables can't reference code because it's only a one-way reference. There's no virtual version of code attached to tables. And when you generate your DAC pack for this complaints code, it's going to include obviously everything in the complaints code project, but also everything in that complaints tables project. It kind of drags this virtual version along with it. At least that's how I think of it. And that's a neat feature, but you might be thinking, why is that? Why do I think so much of this? Why is this the thing that really makes me enthusiastic about this technology? So we'll run through a few examples of how you might use this. And the first example, and the one you may be familiar with, is the circular references problem. And this happens because you want your deployed projects to look something like this. You want a complaints project, or a complaints database and a bookings database, and you want the complaints database to contain a synonym that references a table in bookings. And you want the bookings database to contain a view that references a table in complaints. Now, our first instinct here is we'll create 2 projects and we'll set up some other database references between them. But that's going to fail. And the reason that fails is because these references are actually references to the DAC packs. And these DAC packs are produced when you build these projects. But these builds won't work because each build relies on the other DAC pack already existing. And Visual Studio recognizes this as a problem and just won't let you create those references. So instead of that, we need to do something else. So we create a project called complaints and a project called bookings, and we set up another database reference, and we create that synonym in the complaints project. But then we create a bookings circular ref project, and we put a same database reference in there to bookings, which attaches that virtual version of bookings to our circular ref project. At this point, this project is empty, but it contains everything from bookings in this virtual version. And then we create another database reference to the complaints project, and we create that view in our circular ref. And when we deploy from here, we deploy complaints to complaints, and we deploy circular ref to bookings, because it's going to drag this virtual bookings along with it. There might be a case where you need to deploy bookings as well, because you made a change here, and a change here that references that first change, and a change here that references that second change. And in that case, you need to deploy 1, 2, 3. But usually, you don't need to bother deploying that bookings project. So now we'll move on to a few other less common use case, or less used use cases for this technology. So in this case, we have a database on production called complaints, and then on dev, we want to set up a load of tests to also run. And we want to set up these tests using stored procedures and functions and other objects. But we don't want to create those objects in production. They're kind of dangerous if they get run by accident there. They can do some damage to our production system, and they're just clutter. So instead, we'll create a project called complaints that holds everything that lives in that production database, or everything we want to live in there. And we'll create a second project called complaints tests. And we'll set up a same database reference to complaints, and then we can write our unit tests in there. And now we can deploy complaints out to production, and we can deploy complaints tests out to complaints, dragging the actual complaints objects with it. So this just holds the function, the actual code, and this holds the code plus all of our unit tests. The second use case is more about reusing a little block of code across many projects and many databases. And this is the start of what I refer to as breaking up your monolith databases into reusable Lego bricks of code. So in this example, we're going to look at a little project called utilities. And this just holds a couple of useful code objects. So I've put a tally table function in there and a date list function, and they just return a list of numbers or dates between the inputted values for the function. And they're just little bits of code. They don't do a lot, but they might be useful in a whole bunch of areas. And so I want to have them to hand to reuse. And I want to reuse them as elegantly as possible. So we have our utilities project. And then at some point, I start working on a bookings project for a bookings database. And this project needs a list of dates. You need lists of dates for bookings to decide when, for the person to choose from when they're booking whatever it is they're booking. So we'll set up a same database reference and bring that utilities database into bookings, or utilities project rather. And then at some point in the future, I'm working on a complaints project and I need the tally table in there for whatever reason. So I just set up another reference. And this now has allowed us to reuse that code very easily. And it means that if in the future, maybe I find a bug in my date list function, or I find a more efficient way of doing a tally table, I make that change here. And that change will then propagate out to bookings, and it'll propagate out to utilities and out to any other database or any other project that has referenced this little utilities project. So it's a much more elegant way of managing this reusable code than copy paste. And this third use case is very similar to the second. It's just building on that and making it a little bit bigger. So in this case, I'm going to pretend we work for a company that produces managed travel software. So a client comes to the company and says, we want to set up a travel website and we want you to run the database behind it. And so we build the database and we maintain it, all of that. And I've worked for a few companies that have this kind of business model, that sell this kind of product. And you inevitably end up with a new client coming along and you look at your existing client base and go, well, their requirements are most similar to this client. So we'll copy this database and then we'll start hacking at it and we'll bolt some other stuff on and we'll stick some duct tape over this bit and we'll tie these things together with string and we'll hope it all works out at the end. And database projects gives you a much better way to handle that by having a common code base and then building some bespoke elements on top. And to build that common code base, you probably build a few different projects. So you'd have a core project that's going to handle bookings, because every client wants bookings, every travel company wants you to be able to book. And then we'll have another project for loyalty, because only some travel companies want to have like a point scheme that you earn. And then we'll have another project for complaints, because some companies will want to handle complaints through another in-house system rather than the website, and so on and so on. And then a new client comes along, Big Holiday Limited. You know they're going to want the core. So you've set up the database project for them. You set up a same database reference to core. You look through the requirements, you realize they want a complaint system. So you'll just set up a same database reference to complaints. And then with a week to go before go live, a very panicked account manager comes up to you saying they've realized they need a loyalty program. It's absolutely crucial before they launch the website that it's in place. We'll get a fair chunk of money and a huge reputation boost if we can make this happen. Is it possible? And you say, sure. And you click a few things and you set up a same database reference to loyalty. And there it is. And once you have these core components, however many you're going to have, you can start to build the bespoke elements on top of that. And again, as you're building these bespoke elements, you might see something that actually belongs in core that really every client should have. So add it to core instead, and it'll propagate out to every other client. Or maybe you find a bug in one of your complaints procedures that only shows up under this weird edge case. So you fix it once in complaints and it propagates out to every client. There's no hunting through every client to figure out which clients include this particular store procedure and finding out that it's been changed in some places and does this bug fix still apply to that? It just works. Now, this isn't exactly what the system will look like. It's a slightly simplified version. The actual version will look a bit more like this, because your loyalty and your complaint systems will be built on top of core. And if you have anything like the utilities project, it'll look a bit more complicated again. But the good news is you don't really need to be tracking these references like this. There's no real reason you need to diagram it all out. All you need is when you're documenting Big Holiday Limited, note the things that references. When you're documenting your loyalty, note the things that references. You don't need a diagram of how everything links together. It's not useful and probably confusing. So the next bit I'm going to talk about is a few tips for how to work with this. But before we do that, are there any questions on this?
No, not on this. There was a question from Cornelia about the circular database reference, but you kind of covered that pretty well.
Okay. So there's a few tips here for working like that. Bear in mind the deployed project, so Big Holiday Limited in this case, is going to control your properties, your database properties, and your pre and post deployment scripts. But the good news there is you can chain those pre and post deployment scripts. So although your core post deployment script isn't going to get deployed automatically, your Big Holidays Limited post deployment script can reference that. And if your core post deployment script references other things, they will get scooped up in that reference as well and get executed when you deploy Big Holiday Limited. You also cannot overwrite objects. So you can't, so if there's a view in core, you can't put an alter view statement in Big Holiday Limited and overwrite it. That would be, I think, a nightmare for the validation process in Visual Studio. So instead of doing that, I'd recommend splitting tables out. So if you need new columns, create a new table. Or if you need to make a change to a view or a procedure, create a new object that references that original object. And as an example here, we have a table called complaint details, and our Big Holiday Limited company needs some extra columns in there. So we'll create a second column or second table, complaint details, Big Holiday, to hold those extra columns. And maybe we put a view over the top of it, so any new code we write can reference those as if they're one thing. And then we also have a procedure called resolve complaint that updates complaint details with the result of any resolution. But for Big Holiday Limited, that also needs to update one of the columns we've added here. So we know we'll need a second stored procedure bespoke to Big Holiday Limited, and we could set that up like this. So here we've copied the code from here into here, and then done the usual kind of hack and bolt on and all of that. But that's not particularly elegant. What if we need to make a change to this because we find a bug? We're back to having to remember that for Big Holiday Limited, this code actually lives here. The much better solution is to do this. So this procedure executes, it calls this procedure, which updates complaint details, passes back a success, and then this procedure will update Big Holiday. So this procedure calls the original one and then executes some bespoke code for the client. Now, finally, I want to talk you through referencing a project that's part of another database. And the best way to explain what I mean by that is to show in an example. So here we have our bookings project and our complaints project, and bookings is using the utilities project as part of the database. And these are going to be deployed as separate databases, bookings and complaints. And we want complaints to have an other database reference to bookings, but as part of some of that code, we want to be calling some of the stuff in utilities on bookings. So we want that, but that's not possible. That's a virtual version of a project. We can't reference that directly. So instead, we set up a reference to utilities, and then when we come to deploy, we'll just set the database names in these variables to be bookings. So they're the same thing. This is fine. This works until you have a scenario like this. So again, what we want to do here is complaints needs to reference bookings, and as part of that, it needs to call something in the utilities section of bookings. Now we know what we're doing there isn't that. So what we try and do is this, but that fails. Visual Studio won't allow it because it won't allow multiple references from complaints to utilities. It won't allow multiple references to the same thing. And we get around this by remembering that these references aren't actually references to the utilities project. They are references to the utilities DAC pack. And this DAC pack is just a file, and you can copy files. So what we do here is we create a copy of the utilities DAC pack for every project that has the same database reference to it. And that allows us to set up our other database references without any trouble. And this copy can be done automatically. There's a section in project properties that allows you to write a command line that gets run post build. And so you can just write in there that to copy this file twice, calling it utilities bookings and utilities complaints. And then every time you build utilities, that copy is going to happen. And you just need to keep on adding to that command line whenever you set up new other database references. So this is the end of the last section. Are there any questions at this point?
There are no questions at this. There is a question at this point.
Okay.
Let's see. Is it possible to create multiple copies of a database in different schemas? All tables, views, and stored procedures in schema A additionally created in schema B, where the views and stored procedures in schema B use the tables in schema B.
No, I don't think so. You might be able to do something really clever with... No, there just isn't a way to do that. When you create these tables and views and everything else, they are attached to a particular schema. So if you want to have multiple copies of them throughout different schemas, you do have to create them multiple times. But you can just copy the files and change the schema in the new file.
Awesome. Thank you very much.
This is John. I got another question.
Okay.
So the notion of using the utilities project as a virtual reference, I think, is really, really smart. I didn't know you could do that. So thank you for teaching me that. The question I had was, if I had, and I'm really big into source control. So if I have my projects in source control, if you change the utilities project, do you have to refresh the other projects that are referenced to that? Like, how does that work? Or do you just change the utilities project and it's magically delicious and everything else can see those changes?
So everything else can see the changes, but they won't push out to the server, to your actual databases on servers, until you build again. So in this example here, you make a change to utilities here, you rebuild utilities, and that change propagates to here, and that change will still exist, will then be here, but you will need to set up your automated deployments to know whenever you change utilities, you need to redeploy bookings and complaints and everything else.
Okay, so you have to rebuild the other ones. Okay, cool.
Yeah, any work you do in bookings will run off this new utilities, but there won't be an automatic recognition that you've made a change to bookings, I don't think. I'm not a source control automation expert, but I don't believe it will automatically recognize that.
Do I have to, well, even if I was outside of source control, if I was in that bookings project, do I have to do anything for it to recognize I made a change to the utilities project?
No, if you're in the bookings project writing some code, it will see that utilities project has changed. As soon as you rebuild the utilities and refresh the utilities DAC pack, that propagates through to the bookings project. It just doesn't automatically deploy to the server.
That is really slick.
Yeah, like I say, this is what makes me really excited about this technology, and yeah, why I'm giving this talk on it more than anything else is this concept.
Well, I really appreciate that you did.
It's good to hear. So that is the last section, like I said, but I know I've thrown a lot of information at you. So I'll give a quick summary here of the stuff we've talked about. Projects are not databases. Projects are defining the ideal state of a database, but there's no link between them. You should always work within Visual Studio when you're working with these projects. Let the tool help you use the extra stuff it gives you as much as possible. We've had a little look at some of the different project and deployment settings you can use. There's a lot more there to explore, so go out and have a look and find what's most appropriate for your company and your team. And finally, we've looked at database references, especially same database references, and how you can use them to break up your databases into more reusable chunks of code. So all that's really left to say at this point is a huge thank you to Ben and William for organising the event, and to all the volunteers behind the scenes and the moderators and everyone involved in the event, really. And a huge, huge thank you to Rob for his work mentoring me. The talk, I would say, is at least 10 times as good as it would have been without his help, so thank you. And finally, thank you to everyone for listening. I hope you've learned something. I hope that some of you go away and have a bit of an explore and a play with this technology and see what other uses you can find for it. My contact details are up on the screen. Reach out with whatever you find. or if there are other questions that occur to you, or if I haven't answered one of your questions properly here, please get in touch and I'll do my absolute best to help. Have a great weekend, everyone. There we are.
That was phenomenal, Chris. Thank you so much. And if we
Thank you.
could just keep you around for one more minute, there is actually
Yeah.
one more question. Do you have a project solution strategy? And this is Zermike Sevorg. I'm tempted to make projects for each DB on an instance and place all of them in a single solution. Or should we try to group biological usage together and not on the actual instance? If I didn't make any sense, you can read the question in the Q&A.
No, I think that makes sense. I would usually, like you, group them together in a sort of per instance way. And then if you're using something like the utilities project or something else that's shared, that probably wants to live in its own solution so that it can be referenced, because that may end up on many different instances. So you want to be able to reference that from lots of solutions. But for stuff that's actually going out to live on a solution on live, I would usually keep it in the same, usually keep everything that's going to be on the same instance in live and the same solution in Visual Studio. But maybe you're in an environment where that's going to change a bit more rapidly. Maybe you're moving databases from one instance to another fairly regularly for some reason, in which case group them more by usage.
Cool. Thank you so much. That was the last open question that I can see. And
So
I think that means you're off the hook.
now, actually, well done, buddy. Well done. That was seriously good. What I'd like to do is I'd like just to read some of the comments out. So in the chat, people are saying, this was awesome, mind-blowing. Super talk, Chris. Thank you. Thanks for a great session. Excellent job. Well done, sir. Thank you for sharing all of these tips and tricks. Thank you so much. Ooh, there we go. It's a slow-moving environment, so this is an answer to the question as to what I would do, solution per instance. So you're getting some really super feedback. Well done. You should feel proud. That was excellent.
Yeah!